This module will discuss two important concepts of energy efficiency: thermal boundary and the R value of materials. The thermal barrier of a home is the dividing line between conditioned and unconditioned spaces. So if you take a look at the cross-section of a home, the thermal boundary would define the distinction between what spaces we heat or cool and the outside surfaces. The thermal boundary then becomes our main barrier against heat loss or unwanted heat gain, and all the surfaces of this boundary should be insulated and sealed. And it's important to note that because only some basements or attics and garages are conditioned, that the location of the thermal boundary can be variable in different homes. And one of the first things that you will do as an assessor of a house is to identify exactly where this thermal boundary is, because that will provide some clues as to where you'll look for potential opportunities to improve that barrier with insulation or sealing. So let's take a look at a couple of examples. So this is an enlarged view of the house, but in this case the thermal boundary would just be the first and second floor, and accordingly you would want some insulation on the exterior walls, some insulation in the attic, and in the basement some insulation in the ceiling, and this would create a barrier around the conditioned spaces of insulation. In another case, we often will find the thermal boundary to be extended into the basement, and in this case we would still need our attic insulation and our wall insulation, but now we would need to be mindful of insulating the floor of the basement as well as the basement walls. In this case, we've decided to keep our car nice and cozy and include it inside the thermal boundary with a heated garage. Maybe there's a workshop in there or something as well. So we would need our attic, wall, and basement insulation as before, but in this case now we need to insulate over the floor of the garage, the ceiling, as well as hopefully a good high quality insulated garage door. In some cases we use our attic spaces for occupied space, and in this case part of the attic would be included in that thermal boundary. So once again our wall and basement floored walls are sealed, but in this case we have a bit of unheated crawl space in the attic, so we would need to insulate the floor of that crawl space, as well as these two short walls which we call knee walls. And on top of that we have a special condition where we need to insulate between the ceiling of this third floor and the roof surface, and that might be a place where we need to use some special materials because we might not have enough room for some good insulation in that space. So in this particular case it shows a number of different conditions, and when we have an occupied attic it's more challenging to insulate because we have different types of construction. We have a floor, a wall, and a different type of ceiling condition, and it might actually require different types of insulation materials to insulate all those spaces effectively. So there are a couple places where you could expect to look and find gaps in the thermal boundary. So the rim joist, which is this intersection between the first floor and the exterior wall, is one location. Above that we call it a band joist location, but here again we have a wall intersecting the floor and a potential to have a break in that wall insulation. I mentioned the knee walls being a place where we might have missed insulation or needing to take special attention. And it may be the case that this garage was added, and when we have a joint between old and new construction, there's often also breaks in this thermal boundary. So gaps in the boundaries often occur at joints between floors and between different types of construction, like the home and the garage or a wall and a ceiling. R value is another important term that we use to assess the relative insulating value of different materials. An important thing that we would like to know about a particular wall surface or roof surface is how much heat is lost through that surface per hour through conduction. And the R value is an assessment of how much heat would be lost under some uniform conditions. There's a pretty simple equation that's used to assess this, and it looks something like this, where Q, measured in BTUs lost per hour, is the equivalent of the surface area we're talking about. For example, a 10 foot by 10 foot surface of wall. The temperature difference, measured in this case in Fahrenheit, between the inside and the outside of the surface, and the special term of R value, which is an assessment of the thermal resistance of that material or wall surface. The units of R value are in feet squared, degree Fahrenheit, hour by BTU. And if we solve for Q in this equation, we would end up with BTUs per hour, which is a useful number. And essentially, though, in this case, the most important thing we would like you to understand is that the higher the R value, the better the insulation. But if you're curious about where R value came from and how it's used, this is how it's actually used to assess how much heat is lost through a surface, which might be then used to size an air conditioner or a furnace. So let's take a look at some common insulating materials. You've probably heard of fiberglass bat, which is often used between framing members, and it has an R value of about 2 per inch of thickness. And the thicker we would add the insulation, the higher the R value would accumulate to. We also use variable types of foam, and common ones have an R value of about 5 per inch, which would allow you to accumulate a higher amount of insulation value in a smaller thickness. We also use variable amounts of fibrous insulation, recycled jeans or newspapers. This is often blown or sprayed in place. We also use reflective materials, which can be very thin and also be a radiant barrier instead of a conductive barrier. And we use various types of wraps and sealants to help keep air from passing through gaps in construction materials. Taking a closer look, if we're at the store looking at different types of insulation or considering what to put in our homes, these are some commonly used construction materials and their relative R values in metric units as well as the English units. And you can see that silica aerogel, a very expensive fancy material, R value of 10 per inch. That's excellent. More common materials though are foams that are in the range of 5 per inch, and our fiberglass bats a little bit lower than that, so we need more thickness. And some other types of insulation you might come in contact with that are actually installed commonly today. I see straw bale on here is one of my favorite materials. Not a very great insulating value, but we often build 18-inch thick straw bale walls, so the R value can still end up being very high for the overall wall surface. So essentially the message is to achieve a target R value such as an R19 wall. The higher the R value of the insulation we use, the less insulation we would actually need. This is an important concept and often affects how much we spend for more expensive, higher R value materials when we need to save space, or when we can use less expensive materials with lower R values because we have more room to accumulate large thicknesses, such as in an attic condition.